a different kind of an example over here. If you look at it, right, there is no mention of semi-annually or half-yearly or quarterly, anything of that sort. Here, the problem is very straightforward. It is being calculated annually. So we don't have to do any conversions over here. We basically collect the data and get to problem solving over here. So what are they saying? A certain sum amounts to 5292 in 2 years and to this much in 3 years at compound interest. They are asking us to calculate the rate and the sum. Do we have the sum in the problem? No. So let the sum be x and the rate be r, right? We assume that. Now let's look at two ways over here. Okay, so the first bit they are saying is that the sum x, right, amounts to 5292 in 2 years. So in the first case I have P1, P is equal to x because there is nothing called P1 over here. So amount 1 is equal to 5292. Your duration is 2 years. Okay, the rate remains the same. So I'm going to use the same R over here. Okay, that's the first bit. And the second bit is P is equal to x. Amount 2 is equal to your 45.60. Your term is 3 years. They mentioned it as 3 years, right? And rate remains the same. Rate is consistent across. Okay. So now how are you going to approach this problem? You need to basically do it in bits, 2 times. So I'm going to do something over here. I'm going to do something over here and then equate them and try to get the sum and rate, both of them. Okay, look at it. So what do we have? Amount is equal to, we know that it's P times 1 plus R by 100 whole to the power n. So I'm going to plug in the value. It is 5292 is equal to x times 1 plus R by 100 whole to the power 2. That is what we have got. I'll term this as equation 1. Okay, now go to the right side and do the same thing for the second bit over here. Again, amount is equal to P times 1 plus R by 100 whole to the power n, right? So plug the values. It is 45.60 is equal to x times 1 plus R by 100 whole to the power 3. Now if you look at it, you have got another equation. 2 equations. How are you going to solve it? How are you going to solve it? So what you need to do is that if you look at it, can I do a simple math between the 2 equations? I am going to divide both the equations. Divide equation 2 by 1. Look at it. So I am going to write the equation 2, 555.60 divided by, what do I have? 5292. 5292. On the right side, I have x times 1 plus R by 100 whole to the power 3 divided by x times 1 plus R by 100 whole to the power 2. Looks simple? Okay, so what happens in this particular case? X gets cancelled out. Okay, and you have 3 quantities of 1 plus R by 100 over here. You have 2 quantities of 1 plus R by 100 over here. So this entire bit gets cancelled out with this one. And I'll be left with 1. If you remember the rule, right? A to the power m divided by a to the power m. What do you get? A to the power m minus n. So if I take this bit as a and a, 3 minus 2, I'll be left with 1. So if you, therefore, let me rub this. Therefore, what do I get? So what do I get over here? I get 55560 divided by 5292 followed by 2 zeros because I have removed this one and included 2 zeros, right? So this will be equal to 1 plus r by 100. Look at it. That's what is left over here, nothing else. From here I'll be able to go ahead and calculate r. So when I go ahead and calculate r, I'm going to get 5%. Okay, when you do the math, you're going to get r is equal to 5%. Now plug the value of r in one of the equation. I'm going to plug the value of r in this equation 1. Your equation 1 has 5292 is equal to x times 1 plus r by 100. R is basically 5 now as per what we have got earlier, and this is 2. So when you go ahead and calculate, you will be able to calculate x. X comes out to be 4800. Understood? You need to just do simply put the values, put them together, create equations, algebraic equations, use your mathematical concepts and solve the problem. Great?